Hello. Hello and welcome. This is the Sario Dev Show. This will be the first of hopefully many. The Sario Dev Show will be all about engineering, things you can do on the side, anything related to engineering, and then hopefully relating that to problem solving in your real life as well. So today, first episode, test episode, I decided that on my commute to work, I'll test recording in the car because it'll do two things. One is early thoughts in the day can start to get rolling, and the second thing is it can get me talking early in the day so that even before I get to work, my brain is actually working. I'm not sure if any of you rely on coffee to start your... If I haven't had my first coffee in the morning, basically I'm useless to talk to. So, I'm hoping something like this will mitigate that. And plus, usually I only get time to blog on these certain things, like after hours, in and around hours. But I figured something raw would be so much better. So, today we will start with how do you convince your senior engineer. So if you're a new engineer starting out and you want to try to convince a senior engineer or someone more senior than yourself on, say they get you to do a task and you're trying to convince them that you have a better way and you want to do it a different way. And I find this a common thing, and it turns out to be a common problem for a lot of young engineers. Usually there's two ways it happens, and the first is that you get a task and you get asked to do something in a certain way and you think, this is terrible, I'll do it a different way. You go and do that, and it could be the perfect way, it could be the best execution of the way that you thought it could be. But at the end of the day, the task was X and you produced Y. So from the engineer's point of view, typically you didn't do the job. You achieved zero. So it almost doesn't matter what you did achieve. So, because that was not the task. So what happens is you will say, you get frustrated by that because A, you go, fine, I didn't do the job, but B, it was better and you feel like your work was poo-pooed upon. You feel like anything you do is not really valued and you can't contribute. And you start hating your job. So that's one thing. The other one is you follow it exactly to the T. You never put in any input. You're always thinking that you have a better way, and you hold on to it, and you hold on to it, and you hold on to it. And in the future, when these type of things happen over and over again, you decide to bite your tongue, always having a better way. Well, that's a shame because of the fact that that could mean that you have the better way and you could be helping increase efficiency of your company, of your processes. The other thing is you'll also get resentment and annoyed because it feels like you can't contribute. And what eventually happens is people end up getting into that senior position and start making calls. Well, that's what it feels like anyways. So this is the scenario we're talking about, and the question is, okay, so why is it important to understand how to work around this? Well, like I said, there's the two approaches. You can just do the job, or you can go against it, and if they like it, then maybe you'll be celebrated, and if they don't, you're basically one of those troublesome young engineers that just don't know how to do the work and understand that it was designed that way for a reason. Everyone wants to say, I want to break the rules, I don't want to play in this box, but for me, I wouldn't say that you want to play outside of the box, or you'd never want to break it. I don't want to say you want to stay within the rules all the time, but I think it's to break the rules of a game, you must understand the game. So when you're brand new to the game of the engineering world, for example, and you're out there trying to break rules already, you don't even know what rules there are to break. Okay, you're trying to get fancy with it. No, you what you, especially in your early years and actually all the time, is you're there to learn. You want to maximize your knowledge, and the number one way to do that is to empty your cup, your mind, what you think you know. You might know a subject moderately well, and you go and get a task, and you have to go and do it or execute it or work with a new person that knows a slightly different view. You know nothing. That's the approach you take. Anyway, so you know nothing, and therefore you learn something by learning the game itself. Once you get a certain level, you may or may not realize that their way was actually better that whole time, and you're kind of naive, or you realize, damn, we've been doing this for years or months or whatever it is, and my way would have been way more efficient. It might have been, it might not have been, but you'll never know. So what's my advice? For me, this is what I did actually, because if you work in a company where you have much more senior engineers, you're not the go-to guy. You're kind of supporting them, but you have heaps of ideas. It's hard for you in your mind to not just simply follow it all, especially if you think you can see a more efficient or a better way. But you have to factor in a couple of things. Number one, if you have a better way, okay, then the amount of time it takes you to explain it or to set it up or to experiment with it takes longer than it would have been to do the whole job in the first place, you're not going to win that argument. The reason is because not everything's driven by the efficiency of the job or the best way to do it. Sometimes there are other goals. There's time, there's money, all those extra factors that when you think of a solution, especially in engineering, the solution's not always the technical answer. What I mean is, the most technically sound solution may not be the best solution to go with. Okay? Let me say again, because you have to understand that when you, as an engineer, your mind is all about the technical problem solving. So you say, this is the problem, here are 3 solutions, this one is the best, but you have to factor in everything around it, including from the financial side, timing, resources, and extending to environmental, stakeholders, the whole lot. It actually does matter. You may not need to do, you get taught in uni to do these big SWOT analysis type things, or you don't need to do all that stuff. But you definitely do need to consider those things. You may not need to use that tool, but you start considering which one actually makes the most sense. So the most simplest example is obviously a task that would be better done in one way but takes double the time because of it, then your management's not going to want to listen. But you say, you know what, but if you do it my way, 3 weeks later or the second time or the third time we do it, it'll be more efficient. Here's the thing. You don't know for sure. Your mind tells you that it should be, and probably in theory it will. So how do you then prove your idea, still don't risk, still get the job done, the job that you were asked, but also prove that your idea would have been more efficient and better? And this is actually factors into a bigger topic of change, if you want change. So this is the answer. I'm going to get to the answer right now. So we know now what we're talking about and why it's important. So, for every engineer, they want to improve and grow and understand differences and contribute, but also do their job well, problem solve well. Here's how to do, and here's how I did it. The answer is do both. So when you get asked to do task X, okay, and you say in your mind Y would be so much better, why don't we do Y? You suggest it to your manager, to your senior, or whoever it is, and they say, cool, I need X done. Sometimes it is because they can't explain it to you, but maybe because it's for specific things. Maybe they have considered the thing that you're talking about, but it never works out, or number of reasons. Or they haven't considered it. I mean, and you might be right. So that's fine. You're going to do, so this is what you do. You go and do task X, okay, in your allotted time, in the budget, in the schedule, and do that freaking well. Because the number one thing that gets you recognized is the jobs that you get given, you go and you do them, and you do them well, and then you say, what's the next task? That's how you make an impression. Anyway, so you don't want to lose that. You don't want to lose that. You want to make sure you maintain that reputation that every task that gets thrown at you, you resolve, you can get done. What's next? Boom, you get another one. And you might realize that your conquest to prove that your other way was right might be insignificant, but let's go with you want to prove it, or it will improve everything. When I say do both, then in your own extra spare time, you do it your way. You do method Y. So you've done method X for the company, you've done it really well, you've done it on time, you've done it within the budget, within your work hours. After hours, you go, I'm going to spend an extra hour after today working on method Y. Now, one caveat is obviously no one asked you to do that, no one's paying you to do that. You've already done X, why would they need your Y? But you do a couple things. One of those things is you start to really understand your idea or your thought process as you try to freaking implement it. Because, as we always learn, there's something good in theory, but once you start implementing, you start learning stuff. And what you start learning is there are some questions that you may not have asked of your solution that as you bang it out, you realize, shit, this takes a little bit longer. Or you start going, this is so much better, this is so obvious. Great. You develop the skill to complete task Y. You refine that skill. So that's fine, that's good. Now you're using your spare time usefully, that's great. Anyway, so you go and you build this thing, you complete task Y. You should not go into the next part. So you shouldn't go, hey, boss, supervisor, lead engineer, look at method Y I've done. It's so much better. They might not have time. They might have moved on. They got X, that's submitted. I need you on job Z now, task Z. So your little task Y may be the most insignificant thing. They didn't ask you to do it, don't show it. That's fine. That's fine. But you proved it for yourself if it's faster or not, or more efficient or not, or better or not. For task Z, you say, hey, I've got another method. I should have started at a lower letter. Task A. Task A would get the job done better than task Z. You do both again. Because this is what's going to happen. When you are a young engineer and you're telling all the senior engineers how it is, I have to laugh a little because this is why. As an engineer, and you work at an engineering company, okay, forgetting that you work at an engineering company part. As an engineer, typically in social circles that are non-engineering ones, you're one of the most know-it-all people in the room. You are. You're one of the most know-it-all people in the room. So there's always one person that seems to know everything in a room or in a group. It could be more than one or whatever, but anyway, typically. And at an engineering company, you grab all of those individual people and you put them in a job together. That's an engineering company. Everyone knows everything. Everyone's smart. Everyone knows everything. That's standard. Everyone's got pride behind their answers or their design or their whatever. Everyone's got new ideas. Everyone's got all of that. Sometimes you think, you know what, like this, everyone goes with that guy's idea just because of his position. Maybe, but you have to understand what that person did to get to that position. Sometimes it's just they've been there forever. And that experience just speaks more volumes than you know, some random new engineer. But the other thing is, so this is why I say keep doing it their way, doing it your way, is because One, you get a direct proof of work of the efficiency gains of your new task or method or solution, because you've done both. This is not an arbitrary, I think this will be faster based on my zero experience. This will be, here are the two side by side. This one is ROI positive. Okay? But what happens is the one time, there's going to be, but you have to do it well, especially when you do this show the two tasks thing. You have to do it well, because there's going to be that time where the senior engineer or the manager or whoever it is decides, let's try your thing, your new Fandango thing. Let's try this method. Let's try method Y. Let's try method A instead of X and Z. And because you did it well and you were right, boom, you're now associated. They go in, they use that solution. It was better. You now solidify yourself as the ability to come up with these alternate solutions and start to become a go-to. If that method ends up being really technical, you become the go-to. You start solidifying yourself as the expert in a specific thing. And maybe not that far. Maybe you just get that, at minimum you get the tick, I've recommended something and it came true. You build that up over time. That's how you become a respected engineer. The last part is, why should I do it for free? Why should I use my own work time? Okay, my own work time. Oh, my own personal time, sorry. To complete a work task that would be helping work. Why? True, but actually you were paid for jobs X and jobs Z. If you want change, you need to do something different. You need, the onus is on you to go do the extra work to make the change. No change happens from doing the same stuff the same ways. You won't be the first engineer to think that there's another way to do things. You won't be the last. So if you want change, you need to put in the extra effort to get the change. The other thing is, it's an investment in yourself. You're developing skills Z and skills Y and A. You are. So you're getting it for yourself. And that's how you should approach it. It's for yourself, to prove yourself, to get it done and to see how it works. And now you're getting, the thing is, when you studied or when you started as an engineer, you're doing hypothetical problems with your solutions. Now you're applying your solutions to real world applications, real world problems. So you get better data and you get better learning. So invest in yourself. That's one thing. The second thing is, you get better. You get faster at problem solving and thinking in other ways. The last thing it does is it could humble you, because you can explore your fandangled new way. You get through the whole thing and you think, this is not that good. It's just not that good. And as you implemented the correct solution, you let go of your pride, you let go of your, I know a better way, and you're angry and trudging through their solution, the work-provided solution. You get through it and you do it properly, and you learn what the goals were of the solution, and you start to understand, hey, actually, this was good. This is why I see why they do things this way. I see why X and Z is after. I understand now. Screw my other solution. It probably wouldn't be that good. It's win-win. It's win-win. And the only cost is your effort. To me, why should I put in this effort? Why? Well, then you come to the wrong place. This is a place for, if you're an engineer, like, you don't have to do shit. You don't have to do anything. If you're an engineer and you want to improve, especially in your early years, and you want to make change, this is how you do it. These are the types of things you do. And the more you do it, the better you get at it. Everyone's happy. You're happy. And as the years go by, you keep doing this, you'll know which battles to pick. And what happens is, your problem-solving skills will compound. It's like compounded interest. The more you do this, the better you get. And over time, it's just second nature. It's just, second nature. You don't even think about it. You're already instantly thinking of an alternate solution and working through it in your head and comparing it to the current solution. And eventually, as you go through your years, you're going to be part of some solutions that you decided, yes, this was the best way, and some that you said, this was the change, and that's the better way. And you start ironing that out. And then in later years, someone else will come up and question your so-called best idea that replaced the first one. And then you see what that engineer does. So it's an interesting game. I think that all engineers should be innovating and creating and challenging their creative side, especially if the ones that want to improve. Because, simply put, this is the best job in the world. So you're designed to problem solve. There's never a shortage of problems, and there is always a solution. All right, guys. So that's it. Let's wrap up today's episode. You learned today that we, as engineers, you may want to level up your representation, your respect as an engineer, your reputation. To change the minds of the engineers. It'll take you doing both. Learn their way and do your way, and get the benefits of both scenarios with no expectations that anyone's going to listen to your other way for the self-improvement alone. Then the rest works out the way that I say it does. Alright? So, thanks for listening. If you like this episode, let me know. I'll be back again with another topic, and we'll basically be talking everything to do with engineering. Things I've learned along the way, things that will help you improve in a world where all this senior engineer structure is there, and in a world where there is so much innovation and so many people moving so fast. How do you compete? How do you thrive? We've got the answers here. Thanks for listening.